Okay, I just got done with a refurb job on CPU board B. I'll put the tag back on it. Replaced all the sockets. These guys. And the two RAMs that were socketed, I replaced those sockets because these are those sockets right here that were in the board. And you'll see that they are kind of green, crusty, and corroded. That's not shine, that's like white, fuzzy crust. So those things are garbage. So replace those. I've got all of the sockets replaced. So, and nice and cleaned up, shiny, nice and good. Yeah. Looks like I missed one. Did I really miss one right there? Where was that? No, I didn't miss one. It's that one right there. I think it just bubbled a little bit, I think. Yeah. Yeah, it's fine. It just bubbled up a little bit. Alright, yeah, but it's nice and clean. Good to go, ready to repopulate. I am going to test the two RAMs. It's 2148 RAMs that were in here. I want to go ahead and test those, make sure they're good before I put them back in the board. And then repopulate. Now we can actually start troubleshooting the board. Another thing I wanted to point out about this board, there's a handful of chips on here that were old Texas Instruments chips that had corroded, tarnished, not really corroded, but tarnished silver clad legs. And I went ahead and I cleaned those best I could with some Tarnex. There's two of them right here. I just got what I could off. These two bipolar ROMs right here, these ones came really good and clean. They were tarnished pretty good. And a chip right here, cleaned it up. I think there's one right here, got it cleaned up decently. Yeah, these two. Those two were really bad. Had some corrosion going on too. But these bipolars came really clean. I'm happy about that. So this board's good to go. I'm gonna go ahead and get it all repopulated, situated. Okay, I got the refurbed CPU board on the known good PROM board. And we are running, and it's basically where it was. Running solid, but we got issues. We got no... It looks like there's like no data making its way to this board. There's nothing, because I got no cars, I got no buildings on the side. We've got issues with the top half of the screen on the background slash text, and then our road graphics kind of aren't bad. I think our road graphics are actually kind of good. Well, that's kind of goofy. I don't know what's up with that. That's strange. Yeah, I don't know. I don't know yet. Unless that's a night scene. But we've got to, number one, I want to look at this, I want to look at the background. Remember, that's this section, this area right here is the background. So I want to look at that first. Get that right, and then we'll look at signals that are supposed to come down to this board, which are either corrupted or missing altogether. Alright, well, simple enough. I removed this chip and one of the legs was bent. So I straightened it out and put it back in, and it looks as if our top is now as it should be. So now it just looks like it is yeah, this looks good. So that section's good to go. Nice. Just a bent leg on that one. So now we just have to look at the signals coming down to this board, because I know this board's good. So the problem is the signals from this board. So okay, now I got to shift to a different part of the schematic and start looking at. First thing I want to do is look at these connectors and look at the signals that are on these connectors, and then work back from there. Alright, I'm kind of perusing around this page of the schematic, which is, there's a lot of these connections that go through these guys here. So I'm just kind of going over this, just probing these circuits, and I came to this guy, IC8, which is a 0, 0. 1, 2 out to 3 is an input basically for some circuitry in the back. So I'm just probing IC8, which is right here, and that 1, 2 out to 3 looks like this. There's the first input signal, here's the second, and then the output is this. I'm going to definitely say that's suspect. And then if I continue on to the going on with this chip, we have a signal here, input, input, and the output is always high, which that is possible because you have to have 2 1s to get a 0. And maybe, just maybe, these 1s aren't lining up, but man, I doubt it. I think this chip is no good. I think there should be signal there. And then this one right here, this and this out to this, it looks like this. You have a low and another low, and the output. Now the logic of a 0, 0 is you need 2 1s to get a 0. There are no 1s, so this should be 1 all the time. And the output is that. So this is definitely no good. This is 0, 0. So we can go ahead and mark this guy as red, and I want to look at what that is doing in this circuit. And the question is always, is this signal being held like that, or is this chip just bad? Chances are it's just bad. Yeah. So anyway, yeah, 0, 0. And what I've done here is I've cut away those 2 output pins. You see pin 3 and pin 8 are cut away. And if I probe the actual pin that's in circuit, it's floating. And then if I pin the little, or probe the little nub here on the chip, it's grounded. And the same thing with this one over here. If I probe the pin itself, there's nothing, which tells me this is probably an unused gate. Right? But if I probe the nub, the little nub on the chip, it's grounded. So yeah, this 0, 0 is shorted to ground. and there's a signal that's missing here. So that signal right there goes, oh, it clocks. It's clocking these. Right? Yeah. It's clocking these guys on pin 9. Pin 9 of the 2919s is now floating. It was low all the time, so that was the problem, is these chips right here were not getting clocked. 2919s. And I probed those already, and on pins 3, now it's just low all the time. 4, 5, 6. 11 and 14, yeah. Now it's just low all the time on all of them, on the outputs. There was a signal there though, but it wasn't the proper signal, because those are actually, those signals are this AL and AL and AL and whatever, are also going to this IC50 MB425. What is that? Yeah, I don't know. That's weird. Because I swore that I probed these and I saw signals on 3, 6, 9, and I don't know. No, it obviously wasn't the right signal. So I'm going to go ahead and replace that and see what we get. Replace this 00 here and see what we get. Alright, well, oddly enough, I fixed that part and it is now working as it should. Here's that input, out. There we go. And then in, out. So that fixed that. Yet, this thing now does not boot at all. And I get nothing on the screen at all. I put the fluke on it and I can read the ROMs and the RAM checks are good. With the fluke on this thing, you can read the ROMs and these two RAMs. This one is F000 to F7FF. That's the CPU's scratch RAM, working RAM. And this RAM right here is this one is E000 to E7FF. That's the character RAM. So I was able to do both of those. You will get a control error on the fluke when you try to boot this thing up. Man, that is hot. When you try to boot that, you will get an error. Yeah, it'll give you a control error, but you can read the RAM, you can read the ROMs and the two RAMs, and that's about all. And I was able to do that. So that was not a problem. This thing is super hot. But I don't think that's not an issue though. I don't think. Anywho, yeah, so there you go. I don't know. Fixed that and now the thing has just completely crapped out on me. So who knows? I'm going to keep poking around and see what we can find. It's kind of curious. Now the light stays on too. This light will flash and stay off if it's running properly. So I don't know. We'll keep poking around. We'll Try to figure out what's going on. Alright, so I removed the RAMs and I removed the bipolar ROMs, tested those. They are good. No problem, put them back in the board. The only reason why I pulled these is because these bipolar ROMs, one of these actually provides clocking to some of the 161s, and some of the 161s had no clock, so I'm just doing process of elimination. I removed them, I dumped them in my reader, they're fine, socketed them, put them back in the board. I got to just poking around a little bit and I was like, well, here's a Signetics part, SA. Those are pretty bad. This one is bad. You can tell I got it marked with a red dot. That's the bad part. It's a 109. I got my TTL book out to look at the 109. I just want to look at the outputs and the clock. So on the low side, the clock is on pin 4. So let's take a look at pin 4. And there is no clock. So okay, that's not, I don't care about what the outputs are doing. The outputs are 6 and 7 and they're complementary. 6 and 7. Okay, no problem. So let's look at the other side. The other side, the clock is on pin 12. And there is a clock on pin 12, okay. So the outputs are 9 and 10, and they're complementary. Let's look at regular Q, and okay, just 10 and 9. Here is pin 9. And pin 10 should be the opposite of that. Should be inverted. And this is pin 9. So this chip is bad. I got a 109 right here, and if I just jump it over it, then the game comes back. And we're back to where we were. Yeah, so that 109's got to go. One step at a time. Okay, part replaced, and we are back. We're back to this, which it's just we're missing all of the stuff from this board. And we know that this board is good, so there's a missing signal or something going to this board. So we need to find that. I think I'm going to just take a minute to probe some of the chips with SA and the Fujitsu chips and stuff like that. And check those out. Also, check some clock chips like 161s and 191s and stuff like that. And just make sure that the counters are counting and stuff, because those generally send those kind of signals. Just do that really quick, get that out of the way, and then we'll, if I don't find anything, then I'll dive deeper into the schematic. I did test these RAMs, by the way, and they are good. They were good in my tester. I don't know if I mentioned that, as well as these. Alright, so, well, we're back to this. That's good. I hate it when that happens, when you fix something, and then you turn it back on after you replace a bad part, and it's completely dead. It's like, okay, it makes you second guess, did I mess something up when I fixed this? Did I put a solder blob somewhere? Did something happen? So you kind of chase your tail a little bit, and all the while, it's just another part failed. And just I had no warning of it at all. I would rather this thing come up working after I replace a part, and I can see it and say, okay, that repair worked, and then it dies. But no, it never came back on after I replaced this. It was just completely dead. That was very weird. I hate that. Anyway, okay, we're gonna look into this, and I'm just gonna do some basic poking around for a while. before we delve back into the schematic. Alright. I'm looking at this PAL. And in particular, I'm looking at pin 19. And that's what it looks like. I'll show you. It's like half proper and half not proper. What in the world is that? It's almost, what is that? I'm wondering if we have a bad PAL chip. I might have to remove that and remove another one from another board and see if we have an issue with that chip, because I don't like that signal at all. This is a PAL. It's not it shouldn't look like that. Where'd that go? Yeah. I'm going to go ahead and remove that chip. Because that creates this phase signal that goes over to this 174 right here on pin 2, no, pin 3, out to pin 2. So it's creating this signal, and this signal might not be correct. I don't know. I just don't like that. I don't like that signal. So I'm going to keep this in mind. I'm going to continue to probe some other stuff. But that PAL does, it's under suspicion. And it creates this phase signal that, following it, comes over to pin 18 of all of these chips, which is something, I don't know, POL, whatever that is. I'm not exactly sure what this 2919 is. One of those bit slice, 4-bit, almost like a RAM. Data. Yeah, I don't know. I don't know exactly what that is. Anyway, 2919. Yeah, let me continue poking around, but this guy right here is under suspicion. Or something connected to it, possibly. We'll see. Okay, I think I found my problem. I was probing around on these RAMs, and remember I tested these RAMs. I removed them and tested them. They are fine. But I'm getting no outputs. Now I am. Well, no, I'm not either. This is an enable pin right here. My outputs are just low. Nothing going on. So I'm like, okay, there's something going on there, because these RAMs are in this circuit right here, and it's like a kind of a buffer circuit that's driving these HE signals. Okay. It's like a line buffer circuit that's driving these HE signals, and they're going right there. And I imagine that those are going to the other board. So I looked at this 245, and let's look at this 245 and see what's going on. That's IC 47. That's this guy right here. So let's probe the enable. The enable is high all the time. So this isn't allowing anything through. So that's high all the time. So let's look at that. That's pin 19. And it's this CSB, chip select B. And that signal enables these 157s. And like I said, this is a buffer circuit. But right now it's not buffering anything. It's not doing anything, because this is not allowing these signals through. The data signals from the CPU basically are coming through and being buffered through these two RAMs and then sent. I'm taking it that they're going to the other board with these LE0 through LE8 signals. And those buffered signals come over to these AND gates, and these AND gates aren't doing anything because one of the inputs is always low because the RAM isn't doing anything. So there's no data coming over through here. So I gotta find this chip select B signal and find out why it's not going low at all. Remember, it's right here and it's high all the time. Okay. So we come back, and I'm just looking at the schematic, and I'm looking for chip select B. And come to this, not that page, all the way back to the, is it this page? This page. And I found chip select B. And it's pin 13 of the 16L8 PAL. It's pin 13. So pin 13 is connected to this guy right here. This is high all the time. Well, I will show you what I have going on right now. I pulled pin 13 from the PAL out of circuit. And if I probe that pin, that's the signal that is supposed to be going to this pin. This pin should be floating right now because there's nothing connected to it. This guy's no good. And that was disguising the whole thing, because if I probed this pin, I could see it kind of fighting a little bit, and I will show you that. And I was like, I'm going to just remove that pin, because I think what we have here is we have it being held high by this guy. So let me turn this off. I'll put this back in circuit, and I'll show you what that looked like in circuit. Okay, I have it back in circuit, and let's probe this pin, and it's still high all the time. And if I probe pin 13, you can see it is high, but you can see where it is fighting a little bit. Now what I want to do is just clip this pin. So I'll do that. I'm going to turn it off and do it. Let's just clip this pin. If I can do it. Did that get it? Is it clipped? Yeah, it's clipped. So let's turn it back on. And now if I just probe my clipped pin, there's that signal from that PAL. And if I probe the nub on the chip, high all the time. So this chip was shorted to VCC. Yeah, this is the actual signal supposed to be going to this chip. So that's going to probably fix this board. So let's go ahead and replace that. Okay, I got that 245 replaced with an HP part. Hewlett-Packard 245. And let's fire her up. See if we get some more graphics or not. Well, we got some stuff, but it ain't looking good, is it? We got some stuff, but it don't look good. Well, the one thing that we have done is we've created more circuits that have come alive. So now that we've got this thing working and we've got these RAMs ramming, now we can go down the chain and find out what's going on, because I bet you we go ahead, turn it off, let's remove this chip, and you know what, I might want to put a different one in there. This one might not be a Hewlett-Packard part. That's just what I grabbed. Yeah, see, here we are. I'm going to grab a good Texas Instruments part. There we go. And put that in there and see what, I have no idea what, this is just what I grabbed. And it turned out to be Hewlett-Packard. So who knows? It might be a fine part. I don't know. But we'll put a brand new Tejas Instruments 245 in there. Let's see what it does. Do we get the same? Yeah, we get the same thing. But I'm going to leave that one in there. I'll put this back. This Hewlett-Packard part is this is an in a pinch part. Use in a pinch. Okay. But like I said, now we've actually got data coming down to this board now, but it's obviously no good. So downstream from these RAMs, now that they're ramming, we have 0.8s, and I just have to get back through the schematic and go forward from here. So it's time to start probing around again. Okay, for comparison's sake now, I have put the good CPU board back on, because you remember with the other CPU board right here, I just replaced that 245 and got the RAMs ramming. But remember the PAL. Do you remember when I probed that chip, the pin 19 on that PAL, how goofy it looked? I wanted to compare it to what it looks like on a good board, and here's pin 19. It looks like a normal signal. So here's the question. Is it the PAL, or is it one of these? These 2919s, that pin 19 connects to each of these. So is one of these internally shorted, screwing up that signal? Because that sends data to this board. So is it that pin, or is it the PAL itself, or is it these 2919s? Well, the easiest way to do that is to check is to remove the PAL and remove that PAL swap the two and then look at it on this board. If it looks the same, then I know it's a 2919. So that's what I'm going to do right now. I'm going to go ahead and carefully remove this PAL chip and that PAL chip and swap them and then see what it looks like with the other PAL. I hope it's one of these 2919s because I know I can buy those. The PAL, not so much. I mean, yeah, I can program it. I have the PALs, but it's probably protected, unfortunately. So I'm going to check though. When I remove that, I am going to see if it's protected, because I need to program another set of EPROMs anyway for this board, because I keep swapping the ROMs from that one to this one. I'm tired of that. Because remember, this one had these in it. These ones that I couldn't read these successfully, and they finally just quit working. So you know what I need to do? These things were weird. But I could not dump these. I couldn't read them at all. And then they just finally quit working. So that was very strange. Those are junk. I knew I need to program another set of these for the other board. And then remove this and then remove the other one. And let's do that and I'll be back. At least I'll have I know this PAL's good. Let's see what's going on. Okay, this is the good board. Other PAL. This is the PAL from that board, the one that I'm working on. And I've got it in there and it works. It's not the PAL. And just to be sure, but yeah, I'm positive that's the one. I will put the other one back in here. This is the original one that was in this board. Make sure that's double, triple check, make sure it's incorrect. In the right way. Not incorrect. In the board correct. You know what I mean. Okay. Okay. So yeah, there you go. The PAL is fine, which is good. I'm going to take a minute to go ahead and get my programmer out, and I'm going to program some ROMs for the other board so that I don't have to keep swapping them. And I'm going to try to dump these. I'm going to try. Yeah, so we've got one of these is bad on that other board, corrupting that signal. So which one is it? I don't know. Well, maybe I'll clip the pin to where I can actually solder it back together, and until we free up that signal. It's one of these. Okay, I don't have any of those, unfortunately. Yeah, so gonna have to make an order, I guess. Good news. If I read this in, the key to these is, okay, I actually get something rather than 0000. Now the thing is, will it verify with the RAM? That's the big test. So you go to verify. And yes, it verifies with the RAM. So we were successfully able to save that PAL. So I will create a disk file. And we'll call it, what is this? PA-06R. PA-06R. And enter. Yeah, that's what I'll call it. And then I'll leave a note. I'll put a text note saying its position and file chip type. Why not? Why can you not write? Okay, let me try this again. Let's go enter. I think I have to have .jed. So let's try PA06R.jed. Okay, I got to figure out why it won't write. I'll be right. Okay, apparently it couldn't write to this disk because this disk is probably full. But I was able to write PA06R, which is right here. PA06R. And I wrote it to this disk. Yeah, operation successful. So there you go. Excellent. Now I'll go ahead and program some EPROMs. And check this out. This is what I'm talking about. I put the other PAL in. This is the same PAL, same file, PA06-R. I put this one in and try to load it, and it gives you all zeros. This one is protected. This one was not. That's why I always try doing these, because sometimes you come across one that is not protected. Yeah, it just depends. So one of them was protected and one of them was not. Interesting. Okay, I got my newly programmed EPROMs in the board. I got this thing put all back together. Now, one thing I did notice is this PAL, which is right here, IC22. Pin 19 is actually connected to IC9 pin 3, which is a 174. 174 pin 3 IC9, which is this guy right here. So it does not go directly to these, which is good actually. This is a 174. So what I did was I clipped pin 3. I clipped pin 3, and now we can probe pin 19 of the PAL. And you can see it looks the way that it should. Now if we probe the nub on pin 3 here of this chip, it is floating. Which it should be floating. Which is weird. Why was it bad before? Remember, it was bad before. Yeah. Maybe I'll try reconnecting where I clipped that and see if it goes back to being goofy. Okay, I just kind of soldered that back together. And now it is not goofy. I mean, you saw that it was goofy before, right? There was clearly, we saw that. So, I don't know. Just weird stuff, but we're going to continue on. It's still super messed up. So there's still some goofiness, but yeah, I don't know. That was weird because it was goofy and then it wasn't. Who knows? Who knows? Anyway, we're going to forge ahead and move on to other stuff. All right, I come back to this section. If you remember, this was where we replaced that 245 for that buffer circuit. I got to looking at the 08s here. It's these two 08s. And I have found that pins 4 is always low. 4 and 5. It doesn't matter what 5 does, because 4 is always a 0. This is an AND gate in this circuit. It's creating these LE circuits that go to the other board. If one of these is always a 0, you're never going to get anything but a 0 out of that AND gate. So I automatically was suspecting that that's probably not right. We're 0 all the time. Pin 5 is always busy, and of course your output is always a 0, right? So I've got, well, let me back up. Inputting that guy right there, pin 4, is this IC20 157. So pin 12. And I happen to have, I make comparators out of chips. I usually have one chip with all of the output pins pulled up, and I use it as a comparator. And I can probe the inputs to this 157, and the inputs are busy, they're doing their thing, but the output, remember the output was always a 0? That's the output of the chip down here. If I probe the output of my comparator chip, it does that, see? Yeah, it's low, but it comes up to that, and this is always low. This is the chip itself. It's always a 0. Whereas this guy is not always a 0. Boom. See? There it goes. While this is always 0. Yeah, so this 157 IC20 is no good. IC20 needs to go. Okay, replaced that 157, and now we do have over here pin 4, remember, was the one that was always, now pin 4 is doing what it should do. Here's pin 5 of the AND, and this is the output of the AND gate. So it looks good. Looks like we're getting activity. And what do we have on the screen? Still garbage. This board has issues. Big time. We have 283s here that take data from these, I believe, and add them. I'll have to look at that closer. So we'll have to look at those 283s. And that'll be an analyzer thing. And we have 283s all over the place up here, and 191s. Lots of 283s. There's like 10 of them right through here, I think. Though I don't know if that would be an issue up here, but these ones definitely, and these chips right here as well, are suspect. But we'll continue on, and we'll see. We'll figure it out eventually. It's just there's so much bad stuff on this board. Just got to keep poking along. Alright, once again, just poking around, and I'm poking around on these 157s. Remember, I replaced this one. I've just been poking around on them on the board and looking at outputs, and I came across this guy, and you can see I've got a red mark on it. And the select pin, we're getting a variety of selecting 1s and 0s. And the enable pin, it's always enabled. Input, ones and zeros, very busy. The 1 input, also very busy, ones and zeros. Here's the output. Low all the time. This one right here, input, very busy. Input, once again very busy. Output, low all the time. If I put my comparator chip over it, remember, okay, remember, here's that output, low all the time. My pin is this. On this one, low all the time. My pin is that. So that's 2 bits right there that are no good. Before I even replace that, I'm just going to continue going on these 157s and until I look at all of them. Okay, I replaced that guy, and it's better. It's better, but it's still bad. We're getting there, though. We are definitely getting there. You get to the city, you get to see how it looks. Pretty messed up. But it's better. It's better than it was, for sure. So we have made progress. But we've got more bad stuff on this board. So we'll have to keep doing some digging. But not tonight. I am done for the day. So we'll be back at it tomorrow. Okay, we're back at this. Okay, I'm testing these 2919s. I got the good board in. And what I have done, because I need to just swap these, I've removed all 4 of them from the board that I'm working on, and I've socketed here. Okay? And then I removed 1 from the good board right here. That's my test area. This is the one that was in the board. I marked it green, and then I'm going through testing these, and I've got to these 2. These 2 were fine. I get to this one, and we've got 1 more right here to test yet. But this one is no good. You will see when it comes back. There you go. So we have a bad 2919. One of them so far. So this one is definitely no good. So we will get the red marker out for that guy. Bad. Bad chip. Bad chip. And here is the next chip. And you can see up here, it's goofy. It's not right. It's almost good, but it's not good. And it's really bad down here, see? So, we got another bad one. This one's bad too. So you also get the marker of shame. Bad chip. Marker of shame. So we had 2 good and 2 bad. 2 good ones, 2 bad ones. Okay, this is the board I'm working on. And you can see here I've got 4 chips in it. I had to remove another one from this board. So I removed a second chip from my good board so that I could test this one. Now I've got 4 good chips in this board, and voila. Now we've got a good turbo CPU board. The only circuit that remains to be tested is this chip, and I believe this chip right here. This chip right here is in conjunction with this stuff up here, whatever this does. And this chip here is in conjunction with whatever this, I think this is the audio connector. And this is probably the scoreboard or something like, I don't know exactly what it is. So you got these 2 8255s. These chips right here, these 2 right here, this 8255 and this chip are for this connector, and this one right here is for this connector. So this is going to be a situation, I don't have all those boards and whatnot, so it's going to have to be a situation where the customer is just going to have to tell me if it works or not. And those 2, well, the soundboard, I do have soundboards to work on, so I am going to do soundboards as well, but I'm doing one thing at a time. I'm doing CPU boards right now, and this one is to this point and looking good. Now I did just go on eBay and I bought 15 or 14 of these chips, and let me tell you, it was not cheap. So yeah, but I had to go source, I sourced 14 of these things just so that I can have a few extra. You know, that there was 2 bad in this board. I've got 5 of these boards to work on. Hopefully there's not a ton of them bad anymore. But I'm going to go ahead and, I don't know, I'll probably break this up into a few parts and upload it. This has been a lot of footage for this. But I'm very happy to be at this point now with this board at least to here. And this is nice. It's all new sockets. I've socketed the bipolars and these RAMs. They should have been socketed in the first place. All these RAMs and stuff, it'd be nice if they were socketed. I've changed these sockets. Like I said, the only thing, and I've probed all of the logic, and everything looks okay for these circuits. So I don't know. I hope that these circuits work. So yeah. All right. Excellent. That's going to do it for this part of the video. I'm going to keep recording footage and releasing it, you know, as I see fit. So, all right. We'll see you on the next turbo repair. And if you're watching this and you dig this kind of stuff, please subscribe. And let's try to get this channel to grow a little bit. All right. Thanks a lot, guys. And we'll see you on the next one. Bye for now.